density. What is density? Density is basically mass over volume. Just remember this formula. Density is always mass per unit volume, and that's the definition of density as well. It is how much grams or how much is the mass of an object per unit its volume. Okay, the value of density depends on its the kind of material that exists. It's the nature of that material. If that material is high density, then it would have a high density. It does not matter if you have a small amount of that substance or a large amount of that substance. Objects, you might know this already, objects that are less dense usually float in fluids that are denser. Okay, so if something is less dense, if this is, let's say, water, and I put like a tennis ball on this, usually that would float. Why? Because this ball is less dense. And what does that dense mean? That means mass per unit volume of this ball is less than the mass per unit of the liquid or water that it's floating on. Usually in case of density, solids have higher density than liquids, and the gases have the least amount of density because gases have a very big volume. Liquids have a little bit volume in the middle. Solids have the least volume. So that's why their density is the most. Exception to this is ice. Ice usually floats on water, even though ice is solid. Usually solids are more dense than their liquid form, but ice is one of the exceptions to that. Now, when we look at units, mass is usually measured in grams, right? So if I say density, I can say grams. Over volume is usually measured in liters or milliliters. So the commonly used density unit is gram per ml, or you can also use gram per cubic centimeters, gram per liter, whatever you want to use. Just remember mass over volume. These are some densities of common substances. For example, you can see rubber 1.19, okay, iron 7.87, whereas water, density of water, is it listed here? Liquid water, okay, liquid water right here. Density of liquid water is this 0.789. So if you put iron on it, it is going to basically sink in it because iron is very high density in comparison to water. Okay, but if you mix helium and water together, helium has less density than water, so helium will float on water. What is the density of platinum nugget? That has a mass of these many grams and a volume of these many cubic centimeters. Very straightforward question. Question is asking what is density. Only thing you have to remember is density is mass divided by volume. If you can measure the grams or mass and you can measure the volume, experimentally you plug it into the formula, get your answer. Mass is given to me 224.50 grams divided by volume 10.0 cubic centimeters. That would give you 22.45 gram per cubic centimeters. Now we go by sig figs because this is division. This has 1, 2, 3, 4, 5 sig figs. The bottom one has 1, 2, 3 sig figs. So my final answer should have 1, 2, 3 sig figs. So my number should end at 4. The following digit is 5, which means my final answer will be 22.5 gram per cubic centimeter because I would round this number up. It's equal to 5. Another question, what is the density of metal if 100 gram sample added to a cylinder of water causes the water level to rise from 25 ml to 37.8 ml? Question is asking again density. Density is mass over volume. Is mass given to you? Yes, this is the mass of my object. Is volume given to you? Not really, but the question says when this metal object is dropped into a cylinder of water, the level rises from 25 to 37. So what is happening here? Displacement, which means what is the volume of my object? Volume is 37.8 minus 25.0 ml, which would give you 2.8 12.8 ml. Okay, so that is the volume of my object. Mass is 100.0 grams, 12.8 ml. And I also did sig figs here because this is subtraction. This is 1 decimal place. This is 1 decimal place. So your final answer should have 1 decimal place, which it does. Okay. Solve for this, and that would give you your answer in gram per ml. This is 1, 2, 3, 4 sig figs. This is 1, 2, 3 sig figs. So your final answer should be 3 sig figs. If you plug this into your calculator, it would give you 7.8125. 3 means 1, 2, 3. The following digit is 2. So I'll round the number down to 7.81 gram per ml, or you can do gram per cubic centimeters. That depends on if the question is asking you to find your answer in a given specific unit. If it doesn't specify, just give the answer in whatever unit you feel can be used for density. The second type, this is the second type of question you can get at density. Calculate mass of 41.0 ml mercury. Density is given to you. So what's given to you is ml density, and the question is asking what is mass. Mass means it's asking what is grams. Okay, 2 ways to do this question. One is density is, we know, mass over volume. Question is asking what is mass, so I need to solve for this. Is volume given to you? Yes, volume is right here. Density is also given to me. So if I rearrange this equation, I can solve for mass. How will you rearrange? I'm solving for mass, so I want to isolate mass, which means I need to get rid of volume. So if I multiply this by volume, volume and volume will cancel, which means I should also multiply this by volume. So my equation is reduced to mass is density times volume. Volume is given to you, density is given to you. Plug in your numbers. As long as this volume is ml and density is ml, they'll cancel out and you will get your mass. Okay, this is if you know the formula. But there's a second approach, which is dimensional analysis, which is what we have been seeing so far. If we are working with dimensional analysis, we only work with units. There is no need for us to know the formula. How do we use this? That is, when the density is given to you in question, that's a conversion factor. It's 13.53 grams per ml. Per ml means divide by ml. How can you get this ratio? That means the bottom number is 1. So I can simply expand this and say 13.53 grams is the mass of 1 ml of this substance. So that is your conversion factor to go between grams and ml. And now we start with what we have been doing so far. My starting unit is ml. I need to convert it into grams, and my conversion factor is this, which is density. So I start with 41.0 ml. My starting unit is ml, so I'll put ml in the bottom. 1 ml, 13.53 grams. ml cancels. My final answer is grams, and you're done. Okay, so there are 2 types of questions you can get in density. Question type 1 is when question is asking calculate density. That's question 1. How will you solve this question? You use the formula. Density is mass divided by volume. Plug in the mass, plug in the volume, and you're done. Second type of question is when density is given in question. It's not asking what is density. It's giving you, hey, this is the density. How do you use it? Use your density as a conversion factor. So use density as conversion factor. Expand it like this. Okay, kind of like this. Expand it and then use it as a conversion factor. Let's try one more question. What volume does 100 gram of marble occupy? Density is given to you. Again, when density is given, I know that 4.00 grams equals 1 cubic centimeters. That is my conversion to go between grams and cubic centimeters. And what is cubic centimeter? You need to remember that this is a unit for volume. Cube of meter, centimeter, liters, all of this is units for volume. So now my starting unit is grams. I need to convert this into volume, which is cubic centimeters. How? 4.00 grams is 1 cubic centimeters. So we start with 100.0 grams, multiply it with a factor, gram goes in the bottom, 4.00, 1 cubic centimeter on top, gram cancelled, your final answer is cubic centimeter. So your answer would be 100.0 times 1 divided by 4.00. This is 3 sig figs. This is 1, 2, 3, 4 significant figures. So your final answer should have 3 significant figures. So if you plug this in calculator, it gives you this 25 centimeter cube. But because I need 3 significant figures, I will add a 0 right after with a decimal, so that all of these 3 are significant figures. So it becomes 25.0 cubic centimeters. And that's it. That's density.